Hi guys, this is George Markevich of the Engine Training Group over at Service Training. We're here today to discuss the injector return leakage test. Now it's part of the NEF fuel rail test kit. The part number on that is 380140055. It comes with some instructions, and one of the last tests talks about leakage on the back of the head. So that's what we're going to be discussing today. All right, so before we do the test, let's take a look at some of the components that we're going to need to do the test from the kit. We're going to need a rail cap plug. This is for when you remove an injector line. We need to plug the port that's on the common rail. The next is a cap plug that is for a plastic fuel line. When we remove it, we need to plug that. We'll need a 17mm wrench. We're going to need the measurement cup from the kit so we can measure the amount of return leakage during the test. Next component we can use from the kit is a vacuum pressure gauge, but you can also make up your own line so you don't have the gauge on the end. It's a little easier, a little less cumbersome to deal with. This is not part of the kit, but you can make this up. One of the last components you'll need is some type of stopwatch. Part of the test is measuring how much leakage we have within a minute. I tend to use my phone, but you can use any type of stopwatch that you like. Now, next step is we're going to demonstrate this on a mock-up engine because it's a little bit easier to demonstrate first off before we go to the actual test. First step we're going to do is to remove the line back from the return regulator to the back of the head. That's attached to the galley from all the returns from each injector. It comes out of this port and goes down to return. We need to cap this. The reason we cap it is it is attached to the relief line also. Just in case during the test the relief valve should pop for some reason, we don't want fuel spraying out, so we cap it. The next step is to attach the test line. This is the hose that's going to give a passageway for all our return fuel to be brought up into our beaker for later measurement. To explain a little bit about what this test does and what we're trying to check for, every injector has to have a little bit of leakage in order for it to fire. In the back of the head, there's a little valve here. It's a return regulator, and that's attached to a galley where every injector is attached to that galley for return fuel. Comes out of the back of the head and it drains back to the tank. We took the line off, and now we're hooking up the plastic line so that we can test that measurement. And we have to test it for 60 seconds, provided that the engine is warm to at least 120 degrees Fahrenheit. So we're going to run the test, and we're going to measure how much leakage we have in 60 seconds. Now, different engines, depending on the injectors, will have different types of leakage. For this NEF engine, a 4-cylinder, we can't have any more than 70 milliliters. For a 6, no more than 80 milliliters. But there are different size injectors. That would have different amounts of leakage. Now, one thing to be careful with, just because the injector is bigger does not mean it's going to have more leakage. This is out of a cursor engine, this large one. You need to find out what the specification is for each engine that you do. Today we're going to be doing the 4-cylinder NEF. So I know we cannot have more than 70 milliliters for 60 seconds. Now, the question lies, what if the test fails? What do you check for? It could be from the injector itself. You could have got water inside the injector and it could deteriorate the little check bowl inside, and we have too much leakage. And that's the reason for the test, because we're going to measure that leakage coming out of the head. Another spot on a NEF engine especially, it could be is from an injector tube. The injector tube mates with the injector. The tube itself slides in through the cylinder head, and there's a lock nut in this to make sure it's tight. We'll pull the line off. I loosened the injector tube already. And this is 22 millimeters to loosen this. And that tube, you can see when I move this, it's got some play in it. Now that's pretty excessive, but if you don't do the proper torque on it, it may run fine until the engine warms up, and then you get excessive amount of leakage. It's one of the reasons why the test has to be at a certain temperature. So when you're doing this and working on these injector tubes, make sure you use a torque wrench and torque it properly. There'll be different specs for different size engines. Just make sure that you look it up in E10 what the spec is and torque it properly with the torque wrench. We are plugged into the back of a 4-cylinder NEF engine, more commonly called a NEF engine. We've pulled off the line that goes off the return regulator, and I put on a clear line, and on the line that came off of the regulator, I installed an internal coupler cap. All right, now that we're plumbed in the back of the head, on the other end of the line, we need to have our beaker cup because we're going to do some measuring. Now for the test, we don't want any more than 70 milliliters for this 4-cylinder. And we have to make sure that the engine's warm. So we need at least 120 degrees, 50 degrees Celsius, depending on the way our instructions are reading. Another good thing to have is the jug here so we can start it, because some of these may leak excessively and you want a container there in case that happens. And of course we need a stopwatch, so I'm using my phone here. So I'm going to start this. I've already run it, and you can see the fuel is in the line, because it takes a while for this long hose to fill up. And when it gets all the way up to the top, then I'm going to put it in the beaker cup, and then I'm going to hit the start button. So I need to start the unit first, so let's stick this back into the retainer. It's filling, but it's taking a bit. Start the stopwatch. So after running it for a minute, you want to let it settle, and we're reading, take our reading, and it should be no more than 70 milliliters. And at this point, it looks like we're right at 30 milliliters. So this test shows that the injectors are good. Now what happens if they're not good? That's the next step. So the big question is, what happens when we have too much leakage? At this time, we need to sort of separate each injector and measure it separately. We do that by getting the cap plug. We're going to remove an injector line from an injector. We're going to cap it, or plug it, another term, torque it properly. Then we're going to run the test again. When we're done running it after 60 seconds, we're going to jot that number down, and we're going to move the cap plug, replace the line that we took off. Of course, along the way you want to make sure these are torqued because we're going to run this test again. Remove the next injector line. Cap that. Sometimes this can be challenging for the amount of room that you have. Torque it. Run the test another 60 seconds. Jot that number down. So now we have two numbers, one for this cylinder, one for that cylinder. Then you move it down to the next injector port, torque the old line, run the test again, jot that down. Now we got 3 measurements, one for each injector. And then from here, we'll move on down the line to the 4th one. Once we've run the test the 4th time, we're going to take that reading, compare it to each injector, and look for the one that is vastly different, and that is the injector that is causing the issue. One thing to consider, you have to make sure that the injector tube is seated and torqued properly, because that will also skew the readings and cause excessive leakage. So that's the basis of the injector leak down test. We're trying to locate an injector that is faulty. How did they get faulty? A lot of times it's from water, but don't forget, it also could be from dirt and debris in fuel tanks, or also from you, the technician working on that. Make sure that you're as careful as possible not to get dirt in this fuel system. Is it a hard test to work? Not really. It's a little tedious. Today we did a 4-cylinder NEF engine. Remember, that specification is going to be different for a 6-cylinder, and also for your other cursor engines and such. So make sure you look up the proper spec. But all in all, it's not an overly complicated test to do, and it can help us pinpoint the faulty injector. Make sure that it's not the injector tube. So make sure you check the torque on those before you condemn an injector. Torque tube's tight, what's left is the injector. So there you have it. In the future, we'll be running more tests on different engines. Make sure you check Tech Knowledge under the dealer portal.